So complex systems is largely about the interaction of a lot of moving parts, let's say. And traditionally, the particles or agents or pieces of these complex systems under study were quite simple, um, from atoms in thermodynamics all the way up to birds and flocking. They were just kind of simple rules. But now we're seeing a new kind of complex systems where we can apply a large language model to every agent, every bird in a traditional Boyd's model or ant simulation, icing model, all these classical kind of net logo simulations. We can now extend them to this point where we put an API call, kind of, where the brain, let's just say ChatGPT or some other intelligence that might exist as a local model or somewhere out in the cloud, let's say, simple agents, individual pixels inside of a kind of a cellular automata model, think Game of Life or Langston Ant, now has this capacity to reach out to a ChatGPT kind of model to understand what it should do next at its individual behavior. Think like digital termite models, ant models, Boyd's, flocking, morphogenesis, all kinds of situations where we have a lot of interacting agents. But now these agents can have unlimited intelligence, like data from Star Trek is inside every pixel of your photograph, whatever that might mean. And in the classical joke of enhance, 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 and show me more about this image, you can do that now. That's not impossible, because you have nearly superhuman, or we can approximate, at least in a few years, superhuman intelligence at every pixel, kind of considering all the physics and optics and everything else about it at the same time. I think that's an interesting place that we are now.